Dr. Biplab Patnaik is founder and managing director of LifeLink, a for-profit green social business initiative founded in 2001 focused on soil biotechnology and environmental engineering solutions for rural and urban waste recycling, sanitation, and water quality improvement. Dr. Patnaik.
Good morning to everybody, distinguished panelists and guests. I was told when I was asked to speak that there are a lot of students, but that's why I had prepared a long presentation, but I don't see any students here, so I'll try to make it very fast. So basically I'll be talking about soil biotechnology, ecological engineering group of waste processing. So what essentially the components of this technology is, one is media, one is culture, green plants, and mineral additives. So media, by media we mean soil and engineered soil. By culture means live organisms, green plants, and mineral additives. This is essentially constitute the technology. Before we started this work in IIT Bombay, our experience was most of the treatment plants were failing. When I was a student and I was traveling as a study tour, so most of these plants were shut down. So we were thinking, what could be the prime reason why treatment plants fail? And we understood that fundamentally all the technologies till date developed, the reaction medium was water. So whether it is oxidation, whether it is precipitation, ion exchange, all these reactions mediums were in aqueous phase. And that is where we found is that instead of water, soil could be a better medium for the reactions. So that is why we fundamentally try to re-engineer and have a relook at soil chemistry and soil biology to develop this technology. Now, typically we express efficiency of the treatment plants like this: 90 to 95% removal, or 70%, 60% removal. In today's date, everybody is talking about zero discharge. So any chemical engineer can say that if something is less than 100%, we are not able to recycle it completely. So this incomplete processing will not allow us to make it zero discharge. So we have to recognize that it has to be 100% pure. Otherwise, every cycle we add the pollutants. So we have very sophisticated technologies which we all know, but Ganga still remains polluted, and most of our river beds are polluted. So that is the reason first we have to understand what is pollution. So our traditional understanding is that BOD, COD, some certain amount of parameters which is causing the parameters of pollution. So we try to redefine that it is not just BOD and COD, it is toxic salts, toxic organics in the numerator, and organic food and minerals in the denominator. So this ratio is basically defines pollution. So BOD, COD, which we know, BOD is actually organic food. COD is the toxic organics. So basically, if we do design treatment system which simply removing BOD, it's not going to help us because the toxic components are still there. One more interesting observation is that when treatment plants, or at least 70s, 80s, 90s, we have seen, we are very much concerned about BODs. When we remove simple organic molecules from the wastewater and leave out salts and complex organic matter, that treated water becomes more toxic than the original sewage. We just saw how the pollution is defined. So if you take out selectively organics and leave out inorganics, that becomes more toxic. These things are not generally discussed in textbooks. So, but this is our experience that the complex organics and inorganic salts, heavy metals, they are more priority pollutants than the simple organics which we describe in terms of beauty. So, through Ecotechnology, we are trying to achieve complete treatment of wastewater. Now, what are the indicators of pollution? We all know odor, pathogens, and pests. So, these are the indicators of pollutions. We generally think pests are disease-causing agents, but our understanding from ecology is that pests are only indicators of pollutions. They are not pollutant per se. So treatment approach of waste has been that you have to sift the waste, you have to dilute it, and then you do separations, and then dispose the slugs. So basically, that kind of conventional approach is not going to work. First, you create human excreta solid, and then pour water into it, and then you take it to conventional treatment plant, and then sludge is generated. So it's a cycle which is not completing. So the waste is simply getting transferred from one phase to another phase. So that is why we are talking about utilization. So if you understand the value of waste, start utilizing through natural systems, then we can achieve complete purification. Now we always think that by adding chemicals we can sterilize, we can achieve sanitation. But our understanding is that when you add chemicals into water, you are not achieving any sanitation. We are actually increasing the degree of pollution by introducing a toxic chemical. We discussed about all these aquatic technologies, and there are something called natural technologies. Sand filter, rapid sand filter. This has been, all this on the left hand side of this, all these technologies are in aqueous phase technologies or reactions which is happening in water. And we'll be talking about now why the treatment plants have been suboptimal, have not been able to sustain is because of heavy mechanization, power cost, and wrong choice of technology. In 1980s, we might remember that the entire Ganga action plan, where a lot of biomethanation plants were set up along the Ganga, and most of them did not perform because the sewage strength was so low, biogas never generated. And of course, the large treatment plants, centralized treatment plants, I've seen many such plants in Hyderabad, 300 mld, 400 mld. So what happens that by the time the design is over, the demand has gone up. So you are never able to design optimally based on the flow. And if there is any failure, the entire wastewater has to be discharged untreated. That is what is happening. That is why now so much of discussion about decentralized treatment plants. Typically activated sludge process. Why it is popular? Because it is compact, and of course it can be set up very fast, and it's an aerobic process, and sludge is generated. So for last 70s, 80s onwards, this was very popular technology. But eventually, when municipalities have started using, they found the power costs are so prohibitive, and mechanical breakdown is such that none of these plants are able to perform. So decentralized solution, yesterday we also had DD director was talking about decentralized systems. When we can use natural systems and in a very small community, then we can address this problem in a much comprehensive and better way. Now, centralized treatment systems get promoted because electromechanical systems offer economy of scale and big systems reduce investments for M&D. But it is difficult and to operate and very expensive cost of operation and maintenance. And they spoil the water quality by destroying organic food, which I was talking on in the beginning, that we reduce BOD and we leave out this BOD and minerals. So that is more toxic actually for the environment. So now we are looking at decentralized facilities. We have done this soil biotechnologies commercialized 2001. For the last 15 years, these installations are operating in hotels and in industries. The last 15 years without any breakdown. So we are looking at decentralized facilities which delivers 24/7 and it not just meets the standard but aims towards zero discharge. So why decentralized system is better? Because it facilitates reuse and recycle, makes us responsible by reducing use of toxic chemicals. Use of ecotechnology helps in smooth operation and maintenance, and small units becomes really beautiful. So wastewater treatment is not just checking the water quality, because what kind of gases, greenhouse gases we generate in treatment systems, they are also important. So there has been studies in US and also in India that the amount of greenhouse gases produced in treatment plants are not small, not negligible. So they are significant. Our earliest treatment systems, whether is septic tank, these are all decentralized systems. And when the population is low, it operates without any downtime. The problem is that all these gases, greenhouse gases, are generated within our vicinity, creating air pollution. So that is why we don't want to have it in our premises. The simplest reaction we know that this ammonia with slight pH and temperature alteration can go into air. So we might be thinking that we are removing ammonia in our system through nitrification and denitrification. But actually that doesn't happen, because in India the temperature is such, we can very easily strip this ammonia from the wastewater. So when you design long treatment systems, long transportation systems, actually we are allowing these gases to come out of the system and go into the air. Same thing with hydrogen sulfide, which can very easily come out of the aqueous phase and create air pollution. So the global greenhouse gas contribution from waste and wastewater operations were 2.8% of the greenhouse gas emission. So it is not insignificant, it is significant. And actually there are so much of data on amount of greenhouse gases generated in terms of methane, nitrous oxide and ammonia. So nitrous oxide actually is 21 times more global warming potential compared to methane. And this is the study in Noida wastewater treatment plant, so much of carbon emission happens. And in different, this has been studied in different parts of the treatment plant. So, different options how we can manage these greenhouse gases is sequestration mechanism, which I think Professor Lal is authority on that, so he will be speaking. So soil and green plants and rock minerals have this potential for carbon sequestration. So initially we discussed that how soil can be a good medium for waste treatment. So that's how we are seeing that it has good potential for carbon sequestration. And also rock minerals can be used for sequestration of carbon. So the treatment thing should be that waste reduction should be priority. Treatment should facilitate recycle or reuse, and reject use of toxic chemicals for sanitation and pest control. So treatment plants should be simple, easy to operate, eco-friendly and sustainable. So that is why eco-sanitation technologies are becoming more and more popular. So there is also, we are getting a lot of knowledge from our tradition that garbage and soil both has to go to soil. And traditionally we understood soil how can be used for waste management. It is just that as a chemical engineer we have tried to reduce soil. So then we'll go to the treatment system which are running for 15 years. Green plants are also useful for inorganic removal, pollutant removal and air quality improvement. So basically soil biotechnology has these components: bacteria is the primary consumer, geophagous earthworms which is predator, mineral additives which are used as a process control regulation element in a green infrastructure. This is the gross chemistry, photosynthesis and respiration, mineral weathering. These are the basic reactions which occur. And how different components are handled: oil and grease, pH, suspended solid, odor, BOD, COD, protein, ammonia. The mechanism for all this pollutant removal exists in soil biotechnology system. Typically it looks like a very simple primary treatment where oil and grease, suspended solid removal is there. Then you have multi-stage bioreactors which looks like basically garden. And the cross section looks like this. There is under drain, there is a filter media, then green plants arranged like this. And the waste is distributed from the top and by gravity gets collected in these tanks. And if you want to achieve further purification, you can do multiple recycles to achieve the desired. Simple schematic model. It has a reactor and a tank. You can model it mathematically. You can model it to get the desired pollutant. So simultaneously, it has been modeled to find out rate constants, uptake rate constant, reaction rate constants for BOD, COD, and ammonia nitrate, and also oxygen transfer. So it shows that the saturation oxygen mass transfer constant components mass transfer coefficient is such that it is compared to sparse vessels. Basically, activated sludge process we used to aerate it. So without aeration, using simply natural filters, we are able to achieve the oxygen transfer coefficients comparable to that. Yes. These are the treatment 5 years performance data of different parameters. Reduction of salts. So exceeds environmental norms and cost effective and life cycle cost is compared to conventional technologies. Minimal power usage. Byproducts are green biomass, biomineral fertilizer and soil, and more effective in pathogen removal. Compatible for decentralized model of waste treatment, very low life cycle cost, helps moderate greenhouse gas emission, achieve desired water quality without use of synthetic chemicals in the process. There are several. This is in golf course in Hyderabad, and this is in ITC hotel. This is Bhaji Sultan Tobacco. This is housing colony very close to the house. Treatment plant is Govardhan Eco Village. This plant got several national and international awards for green technologies for our client. This is in Central University, Hyderabad. Students actually have visited these plants because the aesthetics is such that it actually promotes eco-tourism. Further research are also going on to achieve zero discharge by for reduction of salts. Several awards and recognitions is coming for this technology. Thank you.